Hello, my geometers. All right, so Ms. Bacon said you were having trouble with the bullseye problem. So I'm here to give you a little help on it. So what's happening is you've got two pieces of string. One that is 4 inches long. Another one that is 8 inches long. And you've got to make a bullseye with this one, and then the target is right there. Now the kids keep getting to throw stuff over into the target until they get one to get a goldfish and bring it home. But we want to make sure as many kids as possible get a goldfish. So we want to make the bullseye area as big as possible and make the total target as small as possible. Because remember, they keep getting to throw things over until they get one in the target, not necessarily a bullseye. So, how does this work? Well, just a reminder of probability. Probability is the desired outcome divided by total outcomes. So, for example, probability of rolling a 5 or a 6. So you're playing a game, you got to roll a 5 or a 6. No problem. The desired outcomes are 5 or 6. The total outcomes, well, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So it's going to give us 2 out of 6, which is 1/3, 33% chance of rolling a 5 or a 6. Actually, it's 33.3 repeating, to be exact. So, what if we had this problem? Probability of randomly landing in the shaded area. And I'm going to shade this part right here. And I'll also shade this part right here. So let's say you had to land in those spots right there. What's the probability? Well, here's what I'm going to do. I'm going to say, okay, this is 4 and this is 4. So that means this has got to be 2 and this has got to be 2. And this is 2 and this is 2. Well, I want to land in the shaded area. So I'm going to find the shaded area right here. So the desired outcome is the shaded area. And I'm going to find the shaded area. Well, if this is 2, then this has got to be 2, and this has got to be 2. So that's a triangle. So one of the triangles is right there, 1/2. So the area of that triangle is going to be 1/2 the base, 2 times the height, 2, and we're going to get 2. Now there's 2 of those. So that's going to be 4. So the probability of landing, not the probability. So the total shaded area here is going to be 2, and that's another one, 2. So the shaded area is 4. The total area, well, the total area here is this is just a square, 4 by 4. It's not a great drawing, but 4 by 4. So the desired outcome is the shaded area. The total number of outcomes well, we could land anywhere in that square. So that's going to be the area of the square, which is going to be 4 times 4, length times width. And that's going to be 16. So the probability, if the probability is desired outcomes over total outcomes, the desired area is 4. That's a shaded spot. The total area is 16. So that's going to give us a 1 in 4 chance, which is 25%. Or 0.25. So that's a 25% chance of landing in the shaded area here. And if we rearrange this, actually if I cut this here, put it there, move that one down, it actually makes sense. If we move that one up there, move that one down there, hey, that's 1/4 of the square. All right, so what you have to do is you have another constraint though. You've got 24 inches to make a target, all right, and then 8 inches to make a bullseye. What you want to do though is make the bullseye as big as possible so as many kids can get the goldfish as possible. We don't want to take home goldfish with us. We might have to, you know, flush them down the toilet and say, have mass or something, all right? It'd be horrible. So, we got to make something in order to have, I'm sorry, I didn't get much sleep last night. Okay, so we got to have something. The inner one has to be 8 inches. The outer one's got to be 24 inches. All right. So let's say I do the inner one like this. I go, okay, fine. 2 inches here. 1 inch here. 2 inches here. So that's 5. I got 3.5 left. So make it go. There's 5. So I got 3 left. So I got to do 1.5 up. 1.5 inches up and 1.5 inches up. So right here I've got a rectangle and a triangle. All right. So let's say that's my bullseye. That's going to be 8 inches. 1.5 plus 1.5 plus 2 plus 2 plus 1 is 8 inches. Now I've got 24 inches for the string around the outside. So, well, I can't use a rectangle again, so I got to use something else. Actually, I'm gonna keep this one really, really easy. I'm just gonna do a square. So that's gonna be 6 and 6 and 6 and 6. That gives me 24. So what's the probability of landing in here? Right there. What's the probability of landing in there? Well, let's find out. Let's see here. The desired area, the shaded area, that's where we want to land. It's going to be, well, that's just a rectangle. It's going to be a rectangle and a triangle. All right, I can do this. Rectangle is length times width, so it's 1 times 2. The triangle, well, that's 1.5. Right there, that's 1, but that's not the height of the triangle. So I'm going to have to do a side problem here. For a triangle, right here, that's going to be, let me switch this around, give you a different color. This right here is going to be that. So that's going to be 0.5. That's 1.5, and I got to find the height. And I got to do Pythagorean theorem. That's okay though. H squared plus 0.5 squared equals 1.5 squared. All right, so h squared is plus 0.5 squared is 0.25. 1.5 squared is 2.25. So h squared, subtract that from both sides. It's going to be 2, so h is the square root of 2, which is like 1.414 something, 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 something. It goes on forever. So I'm going to take this. So the base of this triangle right here is 1. So it's 1/2 base times height. The base is 1. The height of it is the square root of 2. Okay. So that's going to get us 2 plus square root of 2 over 2 divided by 2, which is going to be like 2.707. That's the shaded area. The total area. Now the total area, that's just a nice easy square. It's the big square, so that's just going to be 6 times 6, which is 36. So what's the probability of landing here? Well, the total number of places I can land is 36. I want to land in a spot that's only 2.707. So I got to take, the probability is going to be 2.707 divided by 36. Let me get my calculator here. I know it's going to be, hey, that rounds up to 3, so it's going to be like 1/12. So, and 1/12 is, what is that? Like 0.8 or something. So let's see here. 2.707 divided by 36. And so the probability is 0.075. Oh, 0.075,194 repeating, which is, we'll just round it and say it's approximately 0.08, which is 8%. 8%. So 8% chance of landing in there. You can do something as simple as this. Obviously, you can't do this one because Mr. Kuhne just did it, but you could do something similar. You could use a circle for it if you want to. All right? But the goal is, the challenge is, who can find the best shape on the inside here to make the game as easy as possible for the kids. So as many kids get to go home with a goldfish. And how can we make this shape on the outside the smallest? So maybe you start doing something like this. Maybe I'm going to do so let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe I make all of these 2 and then make something else on the inside. That could work. So maybe I make like instead of just a house, maybe I make a semicircle and something else attached to it. Okay. But remember, this has to be 8 inches of string total. So that's your goal. Make this thing in the middle as big as possible. Make the outside as small as possible. Now, the more elaborate you make it, you may be able to make it give a better probability of getting the bullseye, but it's also going to take more calculations. So there you go. Inner shape has to have 8 centimeters of perimeter. Outer shape has to have 24 inches of perimeter. Find the area of the inner one, find the area of the whole thing, then find the probability of landing the bullseye. There you go. Good luck. I will give you an extra day on this. So instead of just having to turn it in tomorrow, you can turn it in by the end of the period on Friday. See you later.